Well, here let's review. You remember that when we first got together, we talked about the idea of a function, what that meant, some relation between an independent set with respect to a dependent set. And we called that relation, we said it's a function if no two pair have the same first coordinate. And so then we talked about from there the domain, which would be the independent set. The domain, where we're coming from, and then the range, where we're going. Well, the range depends on those values that come from the independent set. So this is the dependent set. So determine whether or not this relation is a function. Is it a function, yes or no?
No.
So you say no, and the reason why is it looks like we have a problem with these two. They have the same first component. And then we have a problem, I mean, you can stop there, look at that, and say no. But even these two are not good, right? Because you got 6 going to 3, and then you got 6 going to 8. And so a function is a relation of order pair where no two order pair have the same first coordinate or component. And then the domain, what do you say the domain is? 4 and 6, right? Good. And the range? Is it 3 and 8?
Yes, sir.
Okay, all right. Good. Determine whether the following equation defines y as a function of x. Yes or no?
Yes.
Yes. Yeah. The x squared is fine. The y squared is a no, right? Very good. Yeah. Wrong one. So I said yes. Is that good? Perfect. Okay. Do you remember the evaluation where you have a function and you just basically just plug it in? Do you remember that? Okay. So can I move on? All right. Good. I don't know. When I was in school, I didn't really care for. Well, here was the thing. I was probably, if I was diagnosed, I mean, I probably was on the autism spectrum or Asperger's or something like that. And you don't realize stuff like that until maybe you get married, you have kids, and then like one of my sons is on the autism spectrum, and I'm like thinking to myself, that's the way I act. And I'm like, there's nothing wrong with him. There's something wrong with these other guys, man. And but when I was in school, first grade, whatever on up, and I just didn't do well. And I mean, it wasn't diagnosed or anything like that. I don't know if they were even doing anything like that back in the 70s, but you remember, like in math class, they would give you like maybe 100 problems to do, like 100, maybe multiplication, maybe 1,000, whatever. Yeah, I would do like maybe 3 of them, and I would say, I get it. Why do 1,000 when, okay, I did 3, and I get it. Let's don't waste our time. Well, of course you can imagine what happened to my grade, right? So. But here's what I said. Here's what I said as I was growing up. That whenever I became an instructor, I'm going to kind of present my class kind of like the way that I kind of think. No need of me giving you 1,000 questions. If you can get it in 4 or 5, let's just do the 4 or 5 problems. If you get it, let's just move on. So.
Imagine someone turning in, I get it, not do the rest.
Oh yeah. But let me tell you, my grades suffered a whole lot each 9 weeks. So oh man, and but anyway, it was just me. I was just a weird kid, I guess. So here, use the vertical line test to determine if y is a function of x. If a vertical line crosses the graph more than once, then we say that that y is not. Remember, y is not a function. Here, you have the graph that's given. Find the function's domain, that's part A. Part B, find the range, C, from the graph, the x-intercept, and then the y-intercept, and then evaluate there. And I believe we had this one, but just to reiterate again, the domain and range, I think that's really important, just to make sure we got that. So the domain is set to be the set of x values that correspond to the graph, and then the range would be the set of y values that correspond to the graph as well. So the domain, if we look at with respect to the x-axis, and see those arrows there, simply means that this graph is traveling forever in that direction. So it's going on the left, is going up and to the left. So for the x values is going to negative infinity, and then over here on the right, it's traveling up and to the right forever. So for the x values, that would be positive infinity. So our domain would be parentheses negative infinity, comma, positive infinity. For the range, we look at the graph with respect to the y-axis, because I'm looking at the y values, and here the range goes, and we always talk about domain and range, we always talk about going from the least to the greatest. So here, that looks like, what is that, -1 for y? So that's -1 all the way up to positive infinity. So here, the range, and it includes -1 all the way to positive infinity. Let's see if we can pick out the, let me erase this, the x-intercept. Looks like there's a point here and also a point there. So this graph has two x-intercepts. So here we have 0, 0, and then we have, what is that, 4, 0? Does that look about right?
Yeah.
Okay, thank you. 4, 0. And then the y-intercept, well, this value there, that origin, that becomes the x and the y-intercept. So here this is 0, 0. And then what is f of -2? So we find x equal -2, and we go up, and that looks like it's there, and that's 1, 2, 3, 1, 2, 3. So that's 3. And then f of 2, we go to x equal to 2. 1, 2, then we come down, we're there, that's -1. All right, did you check that and make sure I'm good? And I know, by the way, look, if you have your computer on and it's this information, that's fine. I mean, that's good. But don't be in just not my class, but anybody's class, looking at other information. That's I mean, it hurts me when we're at church and the preacher's up there, bless his heart, they're doing their best, trying to give a word, and they got people on their phone, they're just surfing the internet, whatever. I mean, why even go to church if that's what so. All right. So this one, just a word on and the objective behind this problem. The previous problem, the objective was to make sure that you understand the domain and range of a function. The objective behind this, do you understand when a function is increasing, and to identify the interval, and then where the function is decreasing if possible, and likewise identify that interval. So select the correct choice below for part A. If necessary, fill in the answer box. The function is increasing on the interval. We say it's increasing if it's going upward. So here, it looks like with respect to the x value from this point on up. So it looks like x equals to 2. And that goes to positive infinity. And then it's decreasing again. We're going from left to right. So from left to right, this is going from negative infinity all the way over to 2. And just stop me anytime if you have a question about something or a comment. This goes with the previous problem. Select the correct choice. Here, is the function a constant function? Now, if it's a constant function, what does that look like? And that came up even for that constant rate of change. If it's a constant function, is what kind of line? Say it again. Horizontal, exactly. Yeah, no, that's fine. Yeah, that's country talk. Flat line, right? Yeah, that's right. Yep. Straight line, well, that is a horizontal line. Exactly. So if it's constant, it's a horizontal line. That wasn't a horizontal line. It was a curve. So here, there is no interval on which the function is constant. Okay. Yes, sir.
Now, if at any point if it comes in an angle and it becomes
Yes, sir.
constant,
On
that's
that
still
particular
a-
interval. That's right. You're exactly right. If you had a graph, excuse my labor of love of my drawing, just doing, let's say at that point, kind of flattens out, if you will, and then it takes a nosedive. Let's say this is 3, so that's 5. So we'll say for this particular problem is decreasing from negative infinity to 3. It's constant from 3 to 5. And then it's decreasing again, comma, right there, from 5 to positive infinity. That is the Jonah graph, right? He kept going down. Anyway, well, eventually he figured it out, and then he changed the slope. Did you know that math was right there? Anyway, let's move on. Without graphing, determine whether the equation has a graph that is symmetric with respect to the x-axis, y-axis, the origin, or none of these. So if it's x squared, we say that that's symmetric to, you remember?
The y.
The y-axis. Very good. Yep. Now, right now, we're not, the only graph that we have covered are graphs for straight lines, but later on in chapter 2, we'll talk about how to graph all these guys here. And so, for this particular one, you're not required to know how to get this yet. I'm sorry, I'm looking at that backwards. I thought, wow, why did I think this is y equal, I'm thinking x equal to y squared. Backwards. Sorry about that. We find 7. Doesn't look like the lowest point. Okay. I had in mind this graph, x equal to y squared plus 7, which rides along the x-axis. Determine whether the graph of the equation is symmetric with respect to the y-axis, x-axis, the origin, more than one of these or none of these. So if it's y squared, the x-axis, very good. That's kind of what I had in mind, you know, for that previous problem, kind of what I was thinking, but this is y squared. The difference quotient, this is important. So we got a couple of things, but the main thing is to make sure that we know how to get the f of x plus h. Just going to write it here. The function is defined as this. So f of x is -2 times whatever you give me plus 7. But if I give you x plus h, this becomes -2 times parentheses x plus h, close parentheses, plus 7. So -2 times x plus h plus 7. So this difference quotient becomes f of x plus h minus f of x all over h. So this is -2 times x plus h plus 7. That's the f of x plus h. Then it's minus f of x. Do brackets. Put the f of x in there, -2x plus 7. Divided by h. And then we simplify. Yeah, so this is -2x minus 2h plus 7 plus 2x minus 7 all over h. The odd, yes, what was that again? Did I miss, did I leave out a negative?
No, I went ahead and just.
Oh, okay, you got the answer. Oh, okay, for the numerator. Very good. So the -2x plus 2x cancels out. The 7 minus 7. I was going to say that with this, I want you to see this now, and if you're a STEM major and you're required to take calculus, you'll see it over there as well too. But when you're doing this, what happens is terms and the numerator are supposed to cancel out like that. And the only thing that you're to have left are terms that have an h in them. Okay? It could be a sum of things. It could be one thing. It doesn't matter. But whatever's left, there's going to be some h's there. Right? So here, this is -2h. That's all we have left on the top. And then the h is canceled. And then that gives us -2. Okay. All right. Now, if it's a straight line graph, which is what this is, because this is y equal to mx plus b. Well, if that's the case, well, the slope is supposed to be -2. You remember that we said the difference quotient is also the slope. It's the slope of the secant, right? Which, for a straight line, that's all you're doing anyway. You're finding slopes of the secant. Just some fancy jargon for what, right? All right, you do this one. Let me give you a couple of minutes on this guy. I want you to be able to get this because this guy is on the test. So I want you to get it. I want you to do it. So you first want to calculate the f of x plus h. This is 9 times parentheses x plus h, all to be squared, right? You can simplify that. This is 9 times x squared plus 2xh plus h squared. And then you run the 9 through, 9x squared plus 18xh plus 9h squared. So here, this difference quotient of f of x plus h minus f of x over h. And I do, let me apologize to most of you who take your classes serious and are respectful. And I didn't mean for you to see that side of me with the young man. And bless his heart, and I'm going to reach out to him. But that's not the way I am, but I do want you all to be respectful because this is just a part of life, I think. So this is, so I'm not a bad guy. 9x squared. I'm putting the f of x plus h part in, what we found up here. Put that part in now. So this is plus 18xh plus 9h squared. And then minus, because here it calls for this minus f of x. F of x is the 9x squared. All over h. Now you see what cancels out. Anything that doesn't have an h in it goes away. This guy cancels out, right? So the numerator, I'm going to go ahead and factor out a h from these two terms there. So that's h times parentheses 18x plus 9h all over h. So here the h cancels, and then that gives us 18x plus 9h. Were you able to get that? Okay. Good deal. Yes, sir. I thought somebody was saying something. All right. All right. Everybody's good? Okay. Good deal. All right. Do you remember these problems where we give you the slope, we give you a point, and then you're asked to find the equation of the line? So, and all you're using, you remember, is this equation here. Y minus y sub 1 is equal to m times the expression x minus x sub 1. So you just plug it in, right? So is everybody good there? Right? Yeah. Okay, good deal. So let me know if we have to, if you want me to go back and cover something, but if you got it, I'll just move on. Okay. Oh, I can't believe that arrow is there. Doggone it. Oh man, I have to fix that. Again, going back to the objective of how to find the equation of a line. One, given a point and the slope, so we use the point slope form, but then that second objective was how to find the equation of a line, giving 2 points on the line. So you take the 2 points, find the slope, and then once you find the slope, take that slope and just one of those points and just repeat those previous steps, right? So, and sorry, I can't do that. That little arrow thing, man, I hate that. That is weird.
I think it's supposed to be a 3.
Does it look like a 3? 3 comma 6. So we find the slope 18 minus 6 all over 9 minus 3 gives us 12 over 6. So that gives us 2. And then we just take one of these points. I'm going to take the 3 comma 6. So we have y minus 6 is equal to 2 times parentheses x minus 3. So here it says type in the point slope form. That's what that would be. And then the slope intercept form, that's y is equal to, if we simplify this, this is what, 2x minus 6, add 6 on both sides, so we just get y equal to 2x. Right? Does that all sound familiar and look familiar? Okay, good deal, good deal. So, and then the next objective was to find the equation of a line if we know something about parallel lines. So from there, you recall, if the lines are parallel, they have the same slope. So if I know that, then I'm going to use m is equal to -2. And so we have y minus a -6, which is y plus 6, is equal to -2 times x plus 5. And then you can simplify and get y by itself for that second part. Now this quiz is ideally, mimicking the test. So, back with the objectives for the parallel and perpendicular lines, that next problem would have been give an equation and a point, can you find the line that's perpendicular? I won't have one of those on the test. I was going to change that, but then I thought, sometimes what happens in my math lab, in all these things, if a student has already kind of did an assignment, if I go back and change it, it kind of distorts. If nobody has done it, then I can go and make changes and it's no problem. But I try to respect if somebody has already gone in there and did something, so I won't touch it. But it's okay. I think if you get the idea of parallel lines, you know that you're grabbing something from an equation. You're grabbing that slope. And if it's perpendicular, you just take that slope and just take its negative reciprocal and use that guy to find the line that you want. So, and then these questions here, we just talked about those a few minutes ago. Same questions, right? So just want to make sure that you understand that. We talked about that secant. I thought that was important as well. Are there any other questions? All right. So we're going to stop there.